Hi, and welcome to this video tutorial on the Local Government Scenes solution. Local Government Scenes is a collection of ArcGISPro projects that can be used to create and publish a 3D community or city-based scene. Local Government Scenes are organized in different levels of detail and are derived from 2D operational data managed by a department or agency within a local government. Input data required are building footprints and LiDAR. Now, if the point density of your LiDAR is more than 3 feet or 1 meter, we recommend using the basic local government scene project. But if the point density is less than 3 feet or 1 meter, we recommend using the Schematic Local Government Scene project. So let's open up the Schematic Local Government Scene ArcGISPro project. Now the first thing we're going to do is we're going to go to our tasks and hit the first task, which is publish elevation layer. We're going to create elevation layers from the LiDAR data. First thing we want to do is create a last data set. Now the key thing here to look out for is that you set the correct coordinate system of the input LiDAR data. You can use the sample LiDAR data provided or use your own LiDAR data. But make sure that you know the coordinate system of the LiDAR data. And there we have our last data set. And the next thing we want to do is we want to flag our LiDAR outliers. So typically within the LiDAR you could have points like birds or points below the surface that you do not want to include in your surface. So we can set an absolute Z minimum and an absolute Z maximum, and any points that fall within the range of the absolute max and absolute minimum, those are the points we want to include, and anything that falls outside we want to exclude. So we hit run and you can see that already we've got some outliers, and then we're going to reclassify those points in the last data set so they are classified as noise, which is class 18. And now we're ready to create our digital terrain model. So we select the last data set and hit run, and only select class code 2, which is ground. And then we can create our DTM. The input is the last data set. Just give the output raster a nice name, and then make sure that your cell size is approximately the size of the point density of your LiDAR data. The next step is an optional step, but we can use this to burn our building footprints into the surface. So that means that the building footprints will not stick through the surface. So you select the surface you want to modify and you select your building footprints. And then we're going to output what we call the modified surface. And then you can say you want the average of the building footprint modified to that elevation, or the maximum or the minimum. And now we have a modified elevation surface, which we'll see later on in the tutorial. Now the same goes for the digital surface model. We need that as well, but then we just select anything but the ground, basically. So all class codes but the ground, and of course not the noise. We don't want noise either. We give it a good name, and again we're going to make sure that our sampling value is roughly the size of our point density. And the last surface we need to create for this workflow is what we call a normalized digital surface model, where we simply subtract the DTM from the DSM to get a normalized digital surface model. Now we want to also publish it so we can view it in a web scene, of course. And if your data is in feet, we need to convert it to meters. You can skip this step if your data is already in meters. And then we also, just to make sure, we want to reproject it to Web Mercator so it displays nicely in our web scene. So you take your surface and reproject it. Make sure you got the right geographic transformation, and then run. Next thing to do is you can decide either to publish to ArcGIS online or publish to your portal. If you publish to online, then you use this step. We're going to create an elevation tile package. The input is your elevation service in Web Mercator. You can set a minimum cache level. If you look at the help, then you'll see there's some more detailed information there, but typically 12, cache scale 12 is good for cities. You output to a cache directory and you run. And once that's run, it might take it some time. Then we need to share this elevation package to our ArcGIS online account. We set a summary. We can set tags, and then we share it to our online account. Now the last thing to do is on ArcGIS Online, we go to the item and we're going to hit Publish. Here you can give it a nice name. And if you still need to, you can add some additional tags. And then we finally publish the elevation layer as a service. Right, it starts to build cache, but we'll move on to the next step. So like I said, you can also publish to portal. Well, this is not possible yet in ArcGISPro. So we need to do this in ArcGIS Desktop from 10.2 onwards. We right-click on the DTM that we want to publish and say publish a server, publish it to our server. And again, give it a good name. And the only thing we need to do here is go to our caching tab and make sure we're using tiles from a cache and use the ArcGIS Online Bing Google Maps tiling scheme and set the levels down to 19, from 12 down to 19. And then we go to the advanced setting and set the tile format to look and the compression to 0.1 or 0.01. Give it a summary, give it some tags, and we can publish it to our portal. All right, here we have the layer on our portal, and we're done. So let's go to the second task, which is to publish our LOD to buildings. And the first step is what we call calculate building roof form. Now this task will extract, if you like, attributes from the LiDAR data and add them to your building footprint feature class. So you can use your own data or use the sample data provided. Point it to your building footprints, into the DSM, into the DTM, and the normalized DSM that were created earlier. And then you can set a number of parameters like minimum flat roof area. I encourage you to read through the help and see what they actually do. The default values work pretty well, but you can play with these values to see if you can improve the extraction. And then we name our output roof form feature class. And we can say if we want to simplify our buildings or not. Simplification will mean that we take away some vertices to get cleaner building footprints in the process. So we run the process. It might take some time on large feature classes. I ran it on 180,000 building footprints. It took 4 hours. But once it's done, we can 3D enable our building footprints. First thing we need to do is make sure that they're at absolute value. And then we can apply a so-called city engine rule, procedural rule, to the building polygons or roof polygons. So the input layer is our roof forms, and then we add a symbology layer. It's a layer pointing to a rule package. And when we hit finish, we can see that we have our LOD2 buildings with roof forms extracted from the LiDAR. And you see here that in these cases, the extraction went very well. We can see that the extracted buildings really conform to the LiDAR points. But we don't want to check every building individually, so we have a confidence measurement tool that allows us to calculate how well the extraction went, basically. So we input our roof forms and our DSM, and we get a map view that opens up with the building roof forms. And when we classify this by RSME, which is the root mean square error, then we get a good indication of the buildings that had good extraction are in green. Yellow extraction was pretty good, but when we have red, of course, then we need to go in and have a closer look. And we can see here for sure that within this building footprint there were multiple roof forms with different heights. So what we need to do here is we need to go in and manually refine the building footprint. In this case, we need to do segmentation, and we segment out the areas of different elevation. So we're simply splitting the features. And once that's done for each of the newly created polygon features, we can change the attributes, and we go to modify roof form attributes. And in this case, we just want to change the maximum height of the building. And you can see in the left view that it will update instantly because it is a 3D symbol that we have attached. So we'll do this for all of the newly formed building polygons. And then we get a form that represents the building very well. Now there are a number of other parameters that you can play with and modify, which is one is roof form, the other one is roof direction. We support a number of roof forms. I won't go into this in this tutorial, but on the local government pages there is a really good detailed document. The roof form extraction process is very well explained in detail, what the underlying methodology is. And there's also a video on there that goes into detail how to review and refine your LOD2 building footprints. So I encourage you to have a look at this additional video if you need to do review and refine of your LOD2 buildings. Now once we're done, we save our edits and we're ready to publish our buildings to ArcGIS Online or to Portal. So if we go to ArcGIS Online, we simply point to the polygon feature class that we extracted. We give it an output name. Basically, we're turning now the polygons into multi-patch features. And then we're ready to create a scene package that we can share to ArcGIS Online. So that's my new multi-patch feature class. Point it to the cache directory and create the scene package. Then we're going to share this to our ArcGIS online account. You enter the scene package, give it a summary, give it some tags, and hit run. Now then we need to go to our item online, click on the item, and hit publish. You can give it a nice name, and maybe you want to add some additional tags, and hit publish. Now, if you need to publish the portal, there's a slightly different process there. First thing first, we still need to convert the polygons to a multi-patch feature class. But once that is done, then we can sign into our portal. And then in this case, we can click on the multi-patch feature class, hit run, and then the sharing dialog will open. And again, same thing here, just give it a summary, give it some tags, and we can publish the buildings to our portal. And there we are. Now the last step we want to do is we want to create our 3D trees, extract trees from the LiDAR and create 3D objects from them. So we point to the last data set, input our point spacing, our building footprints, and again you can use the default values here for buffer different distance and minimum canopy height and maximum canopy height, but you can also play with these parameters to see if the extraction can be improved. And then we're going to select our tree points and add a rule package to them to create our 3D trees. So if we want to have a look at the result, then we can see that we got nice extraction of trees and we got good extraction of our LOD2 buildings. And the only thing left to do now is to publish our trees to ArcGIS Online or to Portal. And that's basically the same step as publishing the buildings. So we just create a scene layer package from our multi-patch trees. Make sure you switch to the right online account before publishing. And there you have it. So in online, you need to click on the item and hit publish to turn the package into a service. On Portal, it gets published directly. Same thing for portal that we did for the buildings. Make sure you log into your portal, and then you click on your tree layer. Yep, make sure you log into your portal. You click on your tree layer and hit run, and then the sharing dialog will open up. We give it a summary, we give it tags, and we publish. Now, the one thing I forgot to mention is what we can do. You can see that the buildings here have been created with floor lines. We can actually go into the symbology of the buildings and switch off the floor lines. So you will just have nice, clean, white buildings. That's simply done by clicking on the symbology and go into the symbol properties. Now let's create a scene with our newly created layers. We go to ArcGIS Online or Portal and say create new web scene. We give it a title and enter the other parameters and hit OK. We go and add the layers. If you give it the nice tags, you can find them directly. You type in the right tag. There we go. Then we have our modified terrain. We got our 3D trees, and we got our LED2 buildings. And here you see that with the modified terrain, we put the buildings nicely on to the terrain so they don't stick out of them. So that's kind of the advantage of running that optional step of burning your footprints into the terrain. And we can change the base map to, for example, the world imagery. We can also turn on shadows and move the sun around. We can go into the layers and configure the layers if need be. If you don't like the colors of the buildings, you can override the symbology directly in the web scene. And then you might set some slides as well, which is basically bookmarks in the scene, which take into account the position of the sun and also the layers that are visible. And then we save our web scene. All done. Thank you.